Yes, welcome you all back. Today, I would like to give some insight about the mathematical modeling and an emerging trend of technology that is the robotics. Altogether, let's see what is mathematical model. I will give some a general example. Let's start with the linearity. We know that voltage directly proportional to current, the basic Ohm's law. And there comes a proportionality constant like R, which can replace. So V is equal to IR, and we are drawing a graph, we'll be getting a linear graph. And based upon that, we are setting up an experiment. And finally, we are plotting a graph. So all the experiments which are doing in the lab is based upon a mathematical model. In certain cases, a mathematical model cannot define a problem. In such cases, the AI can be used. There comes the dominance of the AI. The probability, we must have a thorough knowledge about the probability, like probability lies between the factors 0 and 1. And when we are talking about the equality term, there won't be a correct equality is not happening anywhere. In the backdrop, you can see a lot of equations are there, a lot of diagrammatic representations are, a lot of mathematical geometrical models are there, a lot of equality signs are there, but actually some errors are there. So these are some fundamental for any design of algorithm or any research. So it's a like back end of all these concepts. Now coming to the topic robotics. The main element of robotic is the brain is the programming part. The hardware to be considered having mechanical structures, then electrical circuits are there, then electronics is there, then finally everything is interconnected. The electrical engineering also coming. So finally, a robot is having different applications. When we are thinking about robot, we used to think a big structure, like this is a robot. In the backdrop, we can see this as a robot, but actually a toy car, a remote control car is an example of robot. A drone is an example of robot. Everything which can do a job, which can replace a human, a substitution for human to some extent. That's an application of robotics. So finally, we can see what's the fundamental of robotics. It is an interdisciplinary branch. It's a collaboration of everything. For example, the structure wants some, for example, a toy car is a robot, but it is not having any much sensors. If I'm using more sensors, then we can develop a humanoid robot also. If our AI is enabled, we can feel like talking to a human being. It can have emotions too. So similarly, the applications of robotics is going on, and in coming years, a lot of research is being happening in this area. So coming to the other area, the artificial intelligence. So now the question is that like robotics was there or not means the answer will be it was there because a toy car is an example of a robot. The embedded system, this can do some that control something where some program is being done and a process is being done. It is an application of some AI or something, but really talking about what is AI in the sense, without any like human intervention, directly it can sense and act accordingly. For example, something is coming to hit me, definitely I am moving. Similar to that, if a development is happening without any control part, there comes the AI because it can think and respond. Recently, I think most of you have viewed a robot playing shuttle, tennis, cricket, and all. So in future, it will be like that only because it can enact like what humans are doing. So everything is clubbed together. So thank you for watching this video, and I'm sure that in coming episodes, all of the speakers or the people involving in this interaction will be sharing more insight on this topic technology. So have a nice day. Thank you for watching. Thank you.